Okay, Archit, you can now start with your introduction. Thank you.
नमस्कार, मी अर्चित गोखले, महाराष्ट्र सेवा संघ विज्ञान विभागातर्फे सगळ्यांचं स्वागत करतो. महाराष्ट्र सेवा संघ विज्ञान विभाग गेले अनेक वर्ष कार्यरत आहे. विज्ञानाच्या प्रसारासाठी अनेक वैज्ञानिक उपक्रम, सेमिनार, वर्कशॉप विज्ञान विभागातर्फे आयोजित केले जातात. नॅशनल सायन्स डे सेलिब्रेशनसाठी अनेक कार्यक्रम आयोजित केले जातात. सगळ्यांच्या सोयीनुसार आपण भाषा इंग्लिश, मराठी, हिंदी मिक्स ठेवणार आहोत. महाराष्ट्र सेवा संघ विज्ञान विभाग started conducting webinars during the lockdown period for propagating science. I am happy to announce that so far we completed 6 webinars with a very good response, and we all are here for our 7th webinar on the topic The Eclipses of the Sun and the Moon by Mr. Shishir Deshmukh. We conducted webinars on a variety of topics including astronomy, mango farming, 3D printing, child psychology during lockdown, etc. Our speaker for the session is a passionate astronomer and has a great command over the subject. He is secretary of Akash Mitra Mandal, an amateur astronomers organization in Kalyan. He has so far discovered 8 SOHO comets. SOHO is an observatory which is a collaboration of NASA and European Space Agency. He became the first Indian discoverer of a SOHO comet. SOHO ने प्रसारित केलेल्या माहितीचा वापर करून कॉमेट किंवा ज्याला आपण धूमकेतू असं म्हणतो ते शोधणारे शिशिर देशमुख हे पहिले भारतीय ठरले. ह्याचा आपल्या सगळ्यांना एक भारतीय म्हणून नक्कीच अभिमान आहे. He has reported many observations of asteroids, minor planets, meteor showers, and variable stars to many renowned institutions like International Meteor Organization, etc. He has received Astronomical Society of India's New Discovery Award for the year 2011. He has been felicitated by auspicious hands of eminent scientist and former President of India, Dr. APJ Abdul Kalam. He has received Adarsh Dombulikar Award, award from Vishwa Samvad Samiti, and many more. He has authored a book named Astronomy of Eclipses with Shri Hemant Mone, President of Akash Mitra Mandal, an NGO situated in Kalyan for propagating astronomy. His research papers are being published in many renowned international journals and publications, with most recent being research paper in January 2019 issue, volume 15 of Journal of Double Star Observations on measurements of 60 double star systems using a small telescope and 4 different methods. He has been writing many popular articles on this uncommon subject. We are definitely looking for interesting information about interesting astronomical phenomenon of eclipse. Now, I would like to hand over to Sachin Waze for some important announcements. Thank you. Hello, Sachin.
Oh, hello. I'm sorry, there was a lag because of some internet issue. Yes, thanks for the elaborate introduction, Archit. Now I would request Mr. Shishir Deshmukh to start with his presentation. Just before that, I would like to tell everyone that we'll be receiving your questions and queries only from this chat box. So keep posting your questions from the chat window. Then after the presentation is done, we will take up a few questions and ask to our speaker, Mr. Shishir Deshmukh sir. So thank you for that, and thank you for joining in. Let's begin and enjoy today's session. Now Mr. Shishir sir, you can start with your presentation. Thank you.
Hello, thank you. Thank you, Sachin. Thank you, Archit. First of all, am I audible? Hello.
Yes, sir. You are very much audible. You can start.
Yeah. Thank you. Thank you, Archit, for that elaborate introduction, and thank you to Maharashtra Seva Sangh Mulund, Vidnyan Vibhag, for giving me an opportunity to share my views with all of you. And I really appreciate carried on by you during this lockdown period, because popularizing science is something is a bit of neglected areas of the societies, and you are really doing commendable work there. So I really appreciate on behalf of Akash Mitra and myself. So today we are going to discuss, as announced, we are going to discuss the eclipses. Eclipses meant the grahana, the eclipses of the sun and the moon. सूर्याची आणि चंद्राची ग्रहण याबद्दल आज आपण बोलणार आहोत. So I'll be starting my presentation. This is a PowerPoint presentation, and I would just tell that I will be starting from very basics, and then we will go to little bit advanced understanding. But before I come quickly to start the subject, I would like to tell you something about Akash Mitra. So Archit has briefly introduced about Akash Mitra Mandal. So Akash Mitra Mandal is a amateur astronomers organization in Kalyan, established in 1986. So we are into 34th year of our tenure, led by Sri Hemant Mone and Sri Prabhakar Gokhale. And over a period of time, we have conducted many programs relating to popularization of astronomy, the studying of astronomy, the kind of what you can say is a research kind of a thing. And we have published also a few papers on behalf of Akash Mitra. So a lot of activities are going on in Akash Mitra. Every Sunday we meet at Kalyan, and we discuss about astronomical topics. As you can say, this is our institute is a pioneer amateur astronomers organization, because we were the first ever organization to organize first ever meet of amateur astronomers meet in India. Then we published a directory of persons associated with astronomy in India way back in 1999, and we gave it free of cost to all the enlisted persons. So thereafter we conducted many programs focused on the popularization of science. For example, we had a coordination with MKCL. Then we designed a course which is online astronomy learning course. Then we also continuously for last 17-18 years we have been participating in science exhibition organized by GMRT Pune, and we are taking our astronomical models there to display, and thereby understanding the making the students understand the concepts, various concepts in astronomy. So then we also work for some underprivileged students in Murbad Taluka. Kind of is a part of our project called Akashase Pustak Vasuya, led by Sri Amit Mone sir. And then we also conduct the basic astronomy course, and then sky watching programs are also conducted regularly. And we have got few automated telescopes at our disposal through which we observe the night sky. So that's all about the Akash Mitra Mandal. Akash Mitra Mandal's email ID is there, which website is also there. You can really ask any question, queries. You can come down. We can easily, once the lockdown is over, you can just come down to Akash Mitra Mandal Kalyan at 4 o'clock, and there is no membership fee we ask to join. So you can always welcome. So that's all about Akash Mitra Mandal Kalyan. So now let us go to today's topic, and that is eclipses of the sun and the eclipses of the moon. So eclipses of the moon are popularly called as lunar eclipses. Lunar eclipses means Chandra Grahane, and solar eclipses, the eclipses of the sun, are called solar eclipses. That is eclipses of the sun, that is solar eclipses, Surya Grahana. The basic question, as I said, I will start from very beginning, and most of you may be aware of many of the things that I will be presenting initially. But I think as we progress in the slideshow, we will go to the little bit advanced understanding, because I learned that this is a heterogeneous group. So beg your pardon if something is very basic to you. Please bear with me for that. So so first we will go to very basics that we have learnt in I think 8th standard. when I was in school, I used to read in 8th standard geography book how eclipses occur. So basically, it is nothing but a shadow play. It's a shadow play wherein three participants are there, three main participants: Sun, the Moon, and the Earth. And because of these three bodies, the celestial shadow play occurs, and we enjoy the eclipses. So new moon might be a new concept for those who have been educating in Marathi medium. New moon is nothing new. New moon is nothing but अमावस्या. अमावस्याला इंग्रजीमध्ये न्यू मून म्हणतात. I don't know why, but it is. New moon means अमावस्या. So new moon comes when the moon comes in between the sun and the earth, and so moon's shadow falls on the surface of the earth, and in that case a solar eclipse happens. So this is a very basic diagram of full moon and new moon. You can see it at the left side. You can see the sunlight, and E is the earth, and in between sunlight and earth you can find moon in the upper section, and in the lower section you can find earth is between moon and the sun. So for the upper section is of a solar eclipse on the new moon, and the lower section is a lunar eclipse, typical lunar eclipse phenomena, and that occurs on full moon. So basically when we talk about eclipses, we must necessarily talk about new moon or full moon. फक्त पौर्णिमा किंवा अमावस्येबद्दलच आपण बोलू शकतो, कारण इतर कोणत्याही तिथीला म्हणजे अष्टमी, सप्तमी, पंचमी या कुठल्याही तिथीला कुठल्याही प्रकारचं ग्रहण होऊच शकत नाही, कारण पृथ्वी, सूर्य आणि चंद्र ह्याच्यामध्ये अँगल असतो. आता तुम्ही पौर्णिमा आणि अमावस्येला तुम्ही बघत असाल समोर, देर इज नो अँगल, ओनली दे आर इन 180 degree, one in one line. But we will see what happens when we really talk about the new moons and full moons and the possibility of eclipses. We'll move on to next slide. Lunar eclipse and full moon. So now the basic question, the lunar eclipse, as I said, happens on full moon. पौर्णिमेलाच फक्त चंद्रग्रहण होतं, आणि आपण जर विचार केला तर जवळजवळ वर्षभरात 12 पौर्णिमा असतात. चैत्र पौर्णिमा, वैशाख पौर्णिमा, ज्येष्ठ पौर्णिमा वगैरे वगैरे, किंवा कोणतेही महिने, इंग्रजी महिने जरी तुम्ही घेतलेत तर साधारणपणे 12 फुल मून्स म्हणजे पौर्णिमा असतात. So isn't that logical that if the lunar eclipse is occurring on full moon, then is it not logical that we should have 12 eclipses? Have you heard about it? No, because it doesn't really occur so. So there is a conflict now. One way we are saying that full moon lunar eclipse occurs, and if there are 12 lunar eclipses in a year, there should be 12 eclipses. It's perfectly logical thinking, but it doesn't really occur so, because things are not that simple as they appear. Right here. So this is a very basic diagram wherein the blue circle, blue plane, is the plane of Earth's orbit. Earth's orbit. Earth's orbit means the orbit in which Earth revolves around the Sun. Orbit of the Earth when the Earth revolves around the Sun. And the second orbit plane I have shown is slightly inclined, and that is the orbit of the Moon, which is making an angle of 5 degrees to the Earth's orbital plane. So blue is the Earth's orbital plane, and this brown color orbit is the orbit of the Moon, which is making an angle of 5 degrees, little more than 5 degrees in fact. So it is just because it is making a 5-degree angle, sometimes it is above the Earth's orbital plane, and sometimes it is below the Earth's orbital plane. In this section it will be above the orbital plane, and in on the left side portion it will be below the Earth's orbital plane. So the moral of the story is, Moon does not move around the Earth in the same plane in which the Earth revolves around the Sun. Very simple. पृथ्वी ज्या पातळीत सूर्याभोवती फिरते त्याच पातळीत चंद्र पृथ्वीभोवती फिरत नाही. या दोघांमध्ये एक कोन आहे, अँगल आहे. त्याची भ्रमण पातळी चंद्राची 5 डिग्रीचा कोन करते. त्यामुळे थोडासा फरक आहे दोघांच्या कक्षांमध्ये. आणि या थोड्याशा फरकामुळे काय होतं ते आपण थोड्याच वेळात बघणार आहोत. ओके, विल मूव ऑन टू नेक्स्ट स्लाइड. So as we said, it is not necessary that on each full moon sun, moon and earth should be on same plane. There can be a difference of plane. The moon may be at the south of the earth's orbital plane, or it may be at the north of the earth's orbital plane, just as we saw this. So in that case what happens is that, supposing this is a diagram of full moon, the sun is somewhere at the left side, and you can see earth's shadow is falling on its orbital plane. It is shown here. And so earth's shadow is falling on its orbital plane, but despite of being full moon, moon is well above this shadow. As a result, it is not caught in the shadow of the earth. So that's why eclipse does not occur. चंद्राची भ्रमण पातळी पृथ्वीच्या भ्रमण पातळीपेक्षा वेगळी आहे या पौर्णिमेच्या दरम्यान. त्यामुळे चंद्र पृथ्वीच्या सावलीत सापडलेलाच नाहीये. चंद्र खूप वरती आहे, उत्तरेला आहे, आणि सावली दक्षिणेला पडलेली आहे, खाली पडलेली आहे. त्यामुळे चंद्रग्रहण या पौर्णिमेला होणार नाही. ही जी काय पौर्णिमा आकृतीमध्ये दाखवली ती ही पौर्णिमाच आहे, कारण सूर्य एका बाजूला आहे आणि चंद्र त्याच्या विरुद्ध बाजूला आहे. पौर्णिमेच्या वेळेस असंच असतं की तुम्ही पौर्णिमेचा चंद्र जर बघितलात होरायझनवर, so you will see that while the sun is setting at the west, the moon is rising, because they are exactly 180 degrees apart from each other. So as the sun sets, moon rises, and in the morning, if you see whole night, if you observe the moon, it will rise, it will come on the overhead, and then it will set in the morning. At the time sun will again rise. So there is an angle of 180 degrees at the time of. It continuously changes because of the moon's revolution around the earth, but full moon's position is 180 degrees away. So the take home message here is, lunar eclipse does not occur on each full moon because of the difference in the orbital planes of the earth and the moon. Moral of the story काय आहे की या दोन पृथ्वी आणि चंद्र ह्यांच्या भ्रमण पातळीच्या मध्ये जो कोन आहे त्याच्यामुळे प्रत्येक पौर्णिमेला चंद्रग्रहण होऊ शकत नाही. जेव्हा ते एकाच प्रतलात असतील आणि पौर्णिमा झाली तरच चंद्रग्रहण होऊ शकतं. एकाच प्रतलात आहे पण अष्टमी आहे, मग काय उपयोग आहे, कारण चंद्रग्रहण होणार नाही, कारण त्यांच्यातला अँगल 180 डिग्री नसेल. त्यामुळे पौर्णिमा तर हवीच, पण ते एका प्रतलात सुद्धा हवेत. दिस इज द डिफरन्स. ओके, आपण पुढे जाऊ. हा, आता हे सर्वात महत्वाचं, राहू आणि केतू. व्हॉट आर दे? आपण खूप ऐकलेलं असतं राहू आणि केतू, खूप ऐकलेलं असतं, कारण राहू हा केतू हे आपण लहानपणापासून ऐकत आलेले असतात. आपण कोणाला मजेत बोलतो की हा माझ्या राशीला हा राहू आहे, किंवा असं बरंच बोललं जातं, खूप निगेटिव्ह बोललं जातं. हे राहू आणि केतू, काही जण ह्याला कुंडलीमध्ये ग्रह वगैरे ह्याचे दाखवतात. परंतु तुम्ही जर आता ॲस्ट्रॉनॉमी मध्ये आपण जर बघतोय, आपण एक विज्ञान शाखेमध्ये आपण आलो आहोत आणि तिथे आपण बघतोय खरं काय आहे आकाशात. हे राहू आणि केतू हा काय प्रकार आहे, सायंटिफिकली व्हॉट इट इज. सो लेट अस सी व्हॉट आर दिस राहू अँड केतू. दे आर व्हेरी इनफेमस, आय नो. सो द होल स्टोरी इज हिअर. दे आर नॉट एट ऑल डेमॉन्स, दे आर जस्ट इंटरसेक्शन पॉइंट्स. दे आर जस्ट इंटरसेक्शन पॉइंट्स, म्हणजे फक्त दोन छेदनबिंदू आहेत. ते दोन छेदनबिंदू जे एकमेकांच्या विरुद्ध दिशेत आहेत. बरोबर छेदनबिंदू कसले, मगाशी आपण बघितलं आहे. सेम डायग्राम आय एम रिपीटिंग हिअर. हा, मगाशी आपण बघितलेलंच आकृती आहे ही. I told you that this is blue one is the Earth's orbital plane and this is Moon's orbit, which is making an angle of 5 degrees. So it intersects Earth's orbital plane in only 2 points, at only 2 points, and these 2 points are called Rahu and Ketu, right? They are called Rahu and Ketu, only intersection points. They are not physical entities. मोठा असा ग्रहासारखा गोल गरगरीत गोळा नाहीये तो. केवळ छेदनबिंदू आहेत 2. मग त्याला एवढं काय घाबरायचं? काही घाबरायचं कारण नाहीये. उलट if you are learning astronomy, if you are interested in eclipses, they are much needed. They are very important to us. They are very important to us because they play a very significant role in eclipses. We'll see that. आता या इथे तुम्हाला कक्षा दिसते, इथे 2 बिंदूमध्ये तो एकमेकांना छेदतोय. पृथ्वीची कक्षा, पृथ्वीची प्रतल, the moon's orbit is intersecting Earth's orbital plane in just 2 points, at just 2 points. One is ascending node, which is called Rahu. Rather other way around, राहूलाच इंग्रजीमध्ये ascending node म्हणतात. आणि एक्झॅक्टली त्याच्या 180 अंश विरुद्ध दिशेस डिसेंडिंग नोड म्हणजे केतू आहे. आता राहू कोणाला म्हणायचं, केतू कोणाला म्हणायचं, हे कसं ठरणार? सोपं आहे. The point from which moon's orbit goes to the north of Earth's orbital plane is called Rahu, and the point where the moon's orbit goes to the south of Earth's orbital plane is called Ketu. Simple. उत्तरेकडे जात असेल चंद्र, ज्या छेदन बिंदू पासून चंद्र त्याच्या कक्षेमध्ये उत्तरेकडे जात असेल तर तो राहू बिंदू, आणि त्याच्या बरोबर विरुद्ध दिशेत जेव्हा तो छेदन बिंदू पार करेल तेव्हा तो दक्षिणेस जाईल. पृथ्वीच्या प्रतलाच्या पृथ्वीच्या भ्रमण पातळीच्या दक्षिणेला तो जाईल. त्यामुळे तो बिंदू आहे केतू. सो दीज 2 पॉइंट्स, राहू अँड केतू, ascending and descending node, and why they are important we'll see in the next slide. So Rahu and Ketu, as I said, they play very important role. What role they play we will see. Right, again, as I told you, so new moon or full moon can occur at any place in the orbit depending on the position of the sun and position of the earth. For full moon, the sun, earth and moon should be in one line. They may not be in one plane, but they can be in one line. So they has to be in one line. So full moon can occur at any place in its orbit, but it is very important if they occur somewhere near to nodes, somewhere near to any node, because at that time all these 3 bodies will be not only in one line but also in one plane. So that makes things interesting, and that is the likely possibility of eclipses. Okay, we'll move ahead. So now we understood that moon comes, sometimes it comes in the orbit, sometimes it comes in the plane with the earth, and you can see eclipse. But what is the nature of Earth's shadow? Because Earth's shadow also plays very important role. Let's see. Sunlight, sun is at the left, and Earth is shown. And because Earth is an opaque body, right? Earth is an opaque body. That's why it creates 2 kind of shadows. Because sun is also not a point source, is an extended source. प्रचंड मोठा सोर्स आहे, ऊर्जा सोर्स आहे सूर्य. त्याच्यामुळे काय होतं, पृथ्वीची जी सावली पडते ती 2 प्रकारची पडते. कारण इकडनं येणारे रेज असे आणि खालच्या साईडने येणारे रेज असे पडून 2 प्रकारच्या सावल्या पडतात. तो both these types of shadows are called umbra and penumbra. घन छाया आणि ऋण छाया असं त्याला मराठीत म्हणतात. घन छाया आणि ऋण छाया, या 2 प्रकारच्या, किंवा दाट छाया किंवा आणि विरळ छाया, हे असेही 2 शब्द आहेत. दाट छाया म्हणजे अम्रा आणि विरळ छाया म्हणजे पेनम्रा, असे 2 शब्द देखील आहेत त्याच्यासाठी. सेम पॉइंट इथे म्हटलेला आहे. 2 प्रकारच्या शॅडो आहेत, अम्रा आणि पेनम्रा. जी डार्क शॅडो असते ती अशी कोनिकल असते. इट इज शंकू असतो ना आपला, शंकू आकृती असते, conical shape shadow, and it is surrounded by penumbra. It is surrounded by penumbra. अम्रा हा शंकवाकृती आहे. अम्रा म्हणजे दाट छाया आणि विरळ छाया ही त्याच्या भोवती आहे. आणि चंद्र या छायांच्या मधून जाणार आहे, कारण चंद्र पृथ्वीभोवती फिरतोय, राईट. आपण बघूया चंद्राच्या पाथवर ही छाया कशी दिसते. So let us take a vertical cross section of Earth shadow. Same diagram आहे, थोडा आपण मध्ये कट करूया तो, and what we will see is here. I think you will be able to see what happens if we cut this shadow somewhere at near the distance of the moon. What we will see, vertical cross section is nothing but two concentric circles. मध्ये आम्रा आहे आणि बाजूला पेनम्रा आहे. दाट छाया मधोमध आहे आणि त्याच्या भोवती बरोबर विरळ छाया आहे. दाट छाया आणि विरळ छाया अशी दोन समकेंद्री वर्तुळ आहेत. समकेंद्री वर्तुळ, कारण दोघांचं केंद्र सेम आहे. ठीक आहे. आता आपण जे बघितले त्या गोष्टी आपण एकत्रितरित्या बघू. पृथ्वीची छाया, नोड म्हणजे पातबिंदू म्हणजे केतू आणि राहू, आणि चंद्राचा पाथ, चंद्राचा मार्ग. आता हीच मगाशी जो क्रॉस सेक्शन आपण बघितला तोच आपण पृथ्वीवरनं आता स्पेसमध्ये बघतोय असं समजा. पृथ्वीवरनं आपण स्पेसमध्ये बघतोय हा असा, आणि आकाशात आपल्याला भले ती दिसत नसली तरी ती तिथे असते, कारण इट इज यू कॅन्ट सी इट बट इट इज देअर, कारण ती शॅडो आहे. अनलेस त्याच्यामध्ये कोण आल्याशिवाय आपल्याला ती दिसत नाही. पण आपण असं धरूया की एक व्हर्टिकल क्रॉस सेक्शनवर आपण काहीतरी एक मोठा पडदा टाकलाय आणि तिथे आपल्याला दिसते. सो what this particular slide is showing is the same vertical cross section that you saw in the previous slide, but as seen from the Earth rather than some vantage point from the space. So this we are viewing from the Earth. So same umbra surrounded by penumbra, and this is obviously the same through the center. This is the plane of Earth's revolution, this dotted line, horizontal dotted line. And at the center it is the Earth's shadow of the center of the Earth's shadow. But as I said, as I have already told you in the previous slides, that moon does not revolve around the Earth in the same orbital plane as the Earth. So it makes an angle. So that's why moon's orbit will be something like this. It is only a 5-degree angle. This may be slightly exaggerated here to understand the nature. So this is the path of the moon, apparent path of the moon, the path of the moon through which moon passes through the shadow. And this is the node, because this is the crossing intersection point. As I said, what is node? Node म्हणजे ascending node किंवा descending node. Collectively they are called node. पातबिंदू आपण त्याला म्हणतो collectively. मग पातबिंदू हा कुठला आहे, कसं ठरणार? जर उत्तरेला जात असेल तर राहू, दक्षिणेला जात असेल तर केतू. तर हा जो नोड आहे असेंडिंग नोड, हा असेंडिंग नोड वाटतोय कारण इकडनं उत्तरेला चाललाय चंद्र. तर हा नोड इथे होता आणि अमावस्या पौर्णिमा झाली तेव्हा पौर्णिमेला चंद्र इथे आला होता. म्हणजे तो इथून पास होईल असा. ही डॉटेड लाईन इथे दिसते. इट विल फॉलो इट्स ऑर्बिट थ्रू both of these shadows. So this is how the trajectory of moon's orbit as far as this particular full moon is concerned. म्हणून तो चंद्र त्याच्या कक्षेत कुठे असताना पौर्णिमा झाली हे फार महत्वाचं आहे. जर पातबिंदूच्या जवळपास कुठे पौर्णिमा झाली तर चंद्रग्रहण होण्याची दाट शक्यता असते. आता तुम्ही बघाल की हे पातबिंदूपासून तो लांब आहे, पण तरीही तो जर इथून जात असेल तर त्याला ग्रहण लागेल. कारण चंद्र हा म्हणजे असा ठिपका नाहीये. चंद्र हा मोठा ऑब्जेक्ट आहे, गोल आहे. त्यामुळे त्याचा सम पार्ट ऑफ द मून विल बी पासिंग थ्रू दिस शॅडोज. सो देर विल बी अन इक्लिप्स. So these are all other kinds of trajectories of moon's position at the time of full moon. So in first case, what happens? Node is far when the full moon occurred. पौर्णिमा झाली तेव्हा नोड जो होता तो फार लांब होता, पण तरी सुद्धा चंद्र विरळ छायेतनं पास झाला. इथून विरळ छाया आहे ना चंद्र पृथ्वीची, त्याच्यामधून पास झाला. त्यामुळे अशा प्रकारच्या ग्रहणाला पेनम्ब्रल एक्लिप्स म्हणतात. ते आपण पुढे बघू. या दुसऱ्या केसमध्ये सुद्धा तो जरा जवळ आलाय, पण साऊथ कडनं गेलाय, दक्षिणेकडनं गेलेला आहे. तिसऱ्या केसमध्ये तो पातबिंदूच्या खूप जवळ आहे. इफ यू कॅन सी बोथ दीज आर स्लाइटली कोइन्साइडिंग, सो व्हेरी क्लोज टू पाथ नोड. तर या पौर्णिमेला पातबिंदूच्या अगदी जवळ असताना पौर्णिमा झाली. त्यामुळे चंद्र अगदी पृथ्वीच्या छायेच्या जवळजवळ मध्यभागापासून जातोय. त्यामुळे त्याचा छायेतला प्रवास हा डीप होता एकदम. त्याचं अंतर हे खूप कमी आहे या तीन केसेसमध्ये. तर या चंद्राच्या पास होण्यामुळे त्याचे चंद्रग्रहणातले वेगवेगळे प्रकार होतात. ते आता आपण थोडक्यात बघू. टाइप्स ऑफ lunar eclipses. We have seen this. Again, we are seeing this. The apparent path of the moon during an eclipse. If moon passes in this way, what will happen? Moon will only pass through its penumbral region of Earth's shadow. Only penumbra. So such kind of eclipses are penumbral eclipses, and such kind of eclipses are little difficult to understand because those who are frequently seeing full moon, they only will be able to identify that there is a slight difference in the intensity of moonlight. So the classic example is just few days back on 5th of June, such kind of eclipse occurred, penumbral eclipse. म्हणजे आपल्या कालनिर्णय किंवा आपल्या कुठल्या निर्णय सागर कुठली जी काही कॅलेंडर असतात त्याच्यामध्ये अशा प्रकारच्या ग्रहणांना मांद्य चंद्रग्रहण किंवा छायाकल्प चंद्रग्रहण असं म्हटलेलं असतं. छायाकल्प चंद्रग्रहण म्हणजे ते अगदी विरळ छायेतनच फक्त जातो, नुसत्या डोळ्यांना ते समजत पण नाही आहे ग्रहण लागले की नाही. सो दीज आर कॉल्ड पेनम्ब्रल एक्लिप्सेस, मांद्य चंद्रग्रहण किंवा छायाकल्प चंद्रग्रहण. पुन्हा एकदा आपण जस्ट बघू पटकन एक एक्झाम्पल घेऊ फक्त की एक 20 नोव्हेंबर 2002 ला एक ग्रहण असं झालं होतं आणि चंद्राचा मार्ग त्याच्या सावलीतनं पृथ्वीच्या सावलीतनं असा गेला होता आणि काही फोटोग्राफ्स मला मी दाखवतो या संदर्भातले. ग्रहण होण्यापूर्वी चंद्र असा दिसत होता आणि ग्रहण मध्याच्या वेळेस चंद्र असा दिसत होता. सो नाउ यू कॅन सी the upper limb of the moon is slightly darkened, right? Slightly darkened. This is because, see this figure at the left. The middlemost position is something similar to this. So at the middlemost position, moon will appear like this. Its upper limb is slightly darkened. So this is how the penumbral lunar eclipse occurs. We'll get to next lunar eclipse. In this case, not only the penumbral shadow but also touches the umbral shadow. म्हणजे केवळ विरळ छायेतनं नाही तर चंद्र त्याच्या दाट छायेतनं सुद्धा जातो. अशा वेळी जे ग्रहण होतं त्याला खंडग्रास ग्रहण म्हणतात. खंडग्रास ग्रहण आपण वाचले असं कॅलेंडरमध्ये लिहिलेलं असतं. खंडग्रास चंद्रग्रहण. पार्शल lunar eclipse. पार्शल lunar eclipse. पार्शल म्हटलं part of the moon is only going through dark shadow. That is why it is partial eclipse. So we'll take one example quickly. This was the path during that lunar eclipse. It occurred on 4th June 2012, and these are the photographs. See how? So this is the path. The arrow shows the path. So first it was here, rightmost figure. So it will coincide with this, the leftmost moon shown in the slide below. It progressed. It was never a full eclipse. So this was a partial eclipse. Now total eclipse, very easy to understand. When moon passes entirely through the umbra or dense portion of the moon. So the dense portion of the shadow, sorry. So that is umbra or total eclipse. खग्रास चंद्रग्रहण, ज्याला खग्रास चंद्रग्रहण म्हणतात ते हे की पृथ्वीच्या दाट छायेतून सुद्धा तो पास होतोय. केवळ नाही तर केवळ दाट छायेतून सुद्धा तो पास होतोय, म्हणून ह्याला अग्रास चंद्रग्रहण म्हणतात. किंवा संपूर्ण ग्रासला जातोय, तो पूर्ण ग्रासला जातोय. एंटायर मून इज कवर्ड इन द शॅडो, डार्क शॅडो. We'll take one example. 29 नोव्हेंबर 93 साली एक ग्रहण झालं होतं and this was These are the various stages in the full moon lunar eclipse. And you can see in the middle of the eclipse, although moon looks very bright, it is eclipsed moon. It is eclipsed moon. And you can see the lower limb is little bit brightened, because you can see in the diagram, the lower limb is closer to the sparse shadow or viral penumbracha jawal hai. Okay, so these are the typical examples of lunar eclipse, and I don't think this is very difficult to understand. It is very easy. So hope everyone understood the basic concept of these lunar eclipses. So now, taking all these eclipses together, so the moon, penumbral, partial, total. Penumbral, partial, total. छाया कल्पग्रहण, खंडग्रास ग्रहण आणि खग्रास ग्रहण, 3 प्रकारचे चंद्रग्रहण होतात. आणि केवळ पृथ्वीच्या 2 प्रकारच्या छायांमधून गेल्यामुळे हे 3 प्रकारची ग्रहण पाहायला मिळतात. Just because it passes through different shadows of the earth, the various types of lunar eclipses are seen. So I think this is easy to understand. Let us move ahead. As I said, the appearance of the moon during the totality, during the total phase of the moon differs. म्हणजे खग्रास चंद्रग्रहणाची आता केस बघतोय आपण. फॉरगेट अबाउट अदर टाइप्स ऑफ लुनार एक्लिप्सेस. खग्रास चंद्रग्रहणात सुद्धा चंद्र फार वेगवेगळ्या प्रकारे दिसतो, आणि हे त्याचं जे दिसणं असतं हे लार्जली, बाय अँड लार्ज, इट इज डिपेंडेंट ऑन दी thickness or opacity or transparency, whatever the transparency of Earth's atmosphere. How? We'll see in this diagram. Very easy to understand. See, you can see that moon is very much in the shadow or dark shadow of the Earth, but still, because of Earth's atmosphere, you can see the gray circle here. Because of Earth's atmosphere, at least some rays manage to reach the surface of the moon, because in this case the Earth's atmosphere must be very transparent. So that's why the rays are reaching moon's surface, and still not exactly dark moon, but little bit reddish moon, of deep red. Even in some cases deep red moon is also observed during eclipse. Or if the atmosphere around the Earth is opaque or it is dark, then very few sunlight manage to reach, and thereby such kind of scenario produces very dark eclipses. I remember one such eclipse that we had seen way back in 1993. The moon was totally vanished in the sky. So that was very dark eclipse. So transparency, and this transparency is not always same. It changes, particularly in the months of, in the era when there is a large eruption of volcanoes. A few years back there had been a great eruption of some Icelandic volcano, and at that time large number of huge amount of ash was prevailing in the upper atmosphere of the Earth, so thereby making that atmosphere pretty opaque, and that might be having impact on the appearance of the dark moon. So that way it is. So here we are coming to the end of our first section, that is lunar eclipses. Now we will go to solar eclipses. So we'll take whatever queries are there later on, as volunteers have already announced. So solar eclipses, as far as geometry is concerned, it is more or less same, only difference is 180 degrees apart. Why? We'll see that. In case of full moon or lunar eclipses, what we saw is Earth comes in between sun and the moon. But in case of solar eclipses, what happens is that it is the moon that comes in between the Earth and the sun. So that's why moon's shadow now falling on the Earth. But in this case also, you can see the orbit is same, the orbital plane is also same, so that angle is also same. So that is why you can easily conjecture that the like full moon, every full moon you don't have eclipses. Likewise, same thing. ऑन एव्हरी न्यू मून और एव्हरी अमावस्येला सूर्यग्रहण असत नाही. ह्याचं कारण सेम. कारण इथे पण आपण चंद्राचीच कक्षा बघणार आहोत, पृथ्वीचीच ऑर्बिटल प्लेन बघणार आहोत आणि दोघांमधला अँगलही तोच आहे. म्हणजे चंद्राची सावली जी पडणार आहे ती प्रत्येक अमावस्येला पृथ्वीच्या दिशेला पडेल असं नाही, पृथ्वीच्या साऊथला किंवा नॉर्थला पडू शकते. दॅट इज वाय ही प्रत्येक अमावस्येला ग्रहण होईलच असं नाही. सो फॉर दॅट मॅटर अगेन नोड्स प्ले व्हेरी इम्पॉर्टंट रोल. इफ द न्यू मून म्हणजे अमावस्या, आता आपण पौर्णिमा विसरून आता आपण अमावस्येबद्दल बोलणार आहोत, कारण सूर्यग्रहणाबद्दल आपण जेव्हा बोलतो तेव्हा केवळ अमावस्येबद्दल आपण बोलायला पाहिजे, कारण अमावस्येलाच सूर्यग्रहण होऊ शकतं. कारण अमावस्येलाच हे तीन जे ऑब्जेक्ट्स आहेत, सूर्य, चंद्र आणि पृथ्वी, हे एका लाईन मध्ये असणार आहेत. सो वी विल टॉक अबाउट ओनली न्यू मून. न्यू मून मीन्स अमावस्या. न्यू मून मीन्स अमावस्या. So just as we saw the various types of lunar eclipses, we have various types of solar eclipses, and solar eclipses at times are extremely beautiful. We'll come to that point later on. There is a huge difference between lunar eclipses and solar eclipses. Solar eclipses, to watch a total solar eclipse or even annular solar eclipse can be a lifetime experience, I tell you, because we have seen many eclipses over a period of time, and those moments were literally unforgettable moments. So first we'll quickly go through the types of solar eclipses. Just as we saw the lunar eclipses, we will quickly go through this because this is very easy to understand. What I would like to talk to you about other aspects of solar eclipses that where I would like to focus your attention on. So we'll just quickly run through these slides. Simple. Here instead of Earth, this is the moon's shadow that will come into picture, and as moon is also an opaque object like the Earth, it will also, and sun is also an extended source of light. So there will be two kind of shadows of the moon, umbra and penumbra again. So here in this case, people in the penumbral region, penumbral shadow on the Earth, they will experience that sun is partially obscured by the moon. Sun is partially obscured by the moon in this way. So that's why this is partial solar eclipse. खंडग्रास सूर्यग्रहण, खंडग्रास सूर्यग्रहण याला म्हणतात. अॅन्युलर सोलार एक्लिप्स. आता अॅन्युलर सोलार एक्लिप्स कदाचित हा जो टर्म आहे हे कदाचित काही जणांना नवीन असेल, काही नवीन नाही, हे आपण ऐकलेलं असतं. अॅन्युलर म्हणजे अॅन्युलस म्हणजे गोल, म्हणजे कंकणाकृती सूर्यग्रहण, की जे आता 21 जूनला होणार आहे. 21 जूनच्या ग्रहणाबद्दल आपण बोलणार आहोत थोड्या वेळाने. आपण पहिले समजून घेऊ ही काय कन्सेप्ट आहे. Sometimes even if the sun, moon and earth in the same plane, the shadow of the moon is not long enough to reach the surface of the earth. एक डायग्राम दाखवतो, त्याच्यावरून तुम्हाला पटकन समजेल. हे बघा, चंद्र पृथ्वीभोवती जो फिरतो ते सुद्धा एका वर्तुळाकार कक्षेत नाही फिरत, त्याची कक्षा देखील दीर्घवर्तुळाकार आहे. आणि ही दीर्घवर्तुळाकार कक्षा असल्यामुळे काही वेळेला तो पृथ्वीच्या जवळ असतो तर काही वेळेला पृथ्वीपासून लांब असतो. म्हणजे आणि हा जो जवळ आणि लांब असण्याचा जो फरक आहे हा जवळजवळ 50,000 किलोमीटरचा आहे. म्हणजे विचारात घ्या की हे किती मोठं प्रकरण आहे. चंद्राचं पृथ्वीपासूनचं जवळजवळचं अंतर साधारणपणे 3,56,000 किलोमीटर आहे. ऍव्हरेज अंतर आहे 3,84,000 किलोमीटर आणि जास्तीत जास्त अंतर जवळजवळ 4,07,000 किलोमीटर अंतरावर आहे. तर समजा एखाद्या वेळी असं होऊ शकतं की अमावस्येला नेमका ते तीनही गोष्टी या एकाच प्रतलात आहेत, मात्र चंद्र पृथ्वीपासून दूर आहे. म्हणजे मी जे 4,07,000 बोललो, समजा त्या अंतराच्या जवळपास कुठेतरी चंद्र असताना अमावस्या झाली आणि एका प्रतलात असतील सर्वजण, तर चंद्राची सावली जी पृथ्वीच्या दिशेला पडेल, ही जी मेन अमरल शॅडो जी म्हणतोय ती तोकडी पडते, ती कमी पडते. बघा, यू कॅन सी दॅट अमरल शॅडो इज फॉलिंग शॉर्ट. इट इज नॉट टचिंग द surface of the earth. What happens is that the reverse cone, reverse angle, that which is making it is made by umbra, is what is touching the surface of the earth. It's a reverse angle. It is called a reverse angle. And what happens to the people who are living in this area, what they will see? They will see that sun is occupied by a black moon, but the moon's disk is smaller than sun's disk. So that is why ring of the sun, the peripheral region of the sun is exposed and it is seen. So that is why you can see an annular solar eclipse. कंकणाकृती सूर्यग्रहण पाहायला मिळतं. कंकणाकृती सूर्यग्रहण, annular solar eclipse. Now again we will go to solar eclipses. Total solar eclipse. Total solar eclipse is very crude diagram, but it is very easy to understand. That's why I kept it. This sun is Earth's orbit, and what you can see here is moon, the tiny moon, and its shadow passing over the surface of the Earth. It's just passing over the surface of the Earth, and people living in those areas can witness a beautiful phenomena called a total solar eclipse or totality. What they will see, the moon is exactly coming in front of the sun, and which is bigger than sun is as it appears from the Earth, and only sun's outer atmosphere, which is called corona. This is not, it has got nothing to do with COVID-19 though. This is the upper atmosphere of the sun. We have been hearing this term for last many years, so we are not afraid, but you also don't need to afraid. This has got nothing to do with corona. This is outer atmosphere of the sun, which is called प्रभामंडळ. प्रभामंडळ म्हणतात सूर्याचं, म्हणजे upper atmosphere, which is very high temperature. It is having very high temperature. So this is the overall geometry of eclipses. So we have seen three kind of eclipses: the partial solar eclipse, annular solar eclipse, and total solar eclipse. Is that all? No. To add some complications, there is one more thing, which is a very critical but very important case, which is called a hybrid solar eclipse. ये hybrid क्या है? Hybrid is, as you know, this comes from this. Maybe this word has come up from the animal husbandry or something, that field. Hybrid means mix, basically mixture of two. So what it has got relevance with the eclipses? See, sometimes the distance of the moon is so critical that the apex of its shadow cone, apex म्हणजे हे शंकवाकृती जी shadow आहे त्याचा जो कोन आहे, त्याचं जे टोक आहे ते जेमतेम पृथ्वीभोवती टच होतं. काही ठिकाणी तर टच होतच नाहीये. म्हणजे इथे हा रिव्हर्स अँगल आहे. मधल्या चित्रामध्ये तुम्हाला दिसतंय इथे तो टच होतोय, आणि पुन्हा या डावीकडच्या चित्रामध्ये दिसतंय तो पुन्हा टच होत नाहीये. म्हणजे जस्ट बिकॉज कर्वेचर ऑफ द अर्थ मुळे हा टच झालेला दिसतोय. म्हणजे पीपल लिव्हिंग इन द राईट मोस्ट एरिया, दे विल एक्सपिरियन्स which kind of eclipse? Annular eclipse, because it's a reverse angle. But this is not a reverse angle, middlemost. This is a normal angle. So these people will see a total solar eclipse. And again, these people, those who are in extreme left, they will see again a annular solar eclipse. So that's why it's a mixed eclipse. Annular, total, annular. Same eclipse, but seen as different from different locations across the earth. So that's why it is hybrid eclipse, a mixture of annular, total, annular, ATA, annular, total, annular. म्हणजे काही ठिकाणावरनं कंकणाकृती, काही ठिकाणावरनं खग्रास, काही ठिकाणावरनं पुन्हा कंकणाकृती. कारण पृथ्वीच्या कर्वेचरमुळे जस्ट काही ठिकाणी ते शंकवाकृती सावलीचा स्पर्श होतो, आणि या स्पर्श झालेल्या भागातूनच केवळ तुम्हाला खग्रास ग्रहण दिसू शकतं. बाकीच्या या दोन ठिकाणावरनं तुम्हाला हे ग्रहण कंकणाकृती दिसेल. म्हणून हे मिक्स प्रकारचं, त्याला मराठीत संयुक्त ग्रहण म्हणू शकतो आपण. संयुक्त म्हणजे दोन प्रकारचं ग्रहण. तर आता आपण चार प्रकारची ग्रहणं बघितली: पार्शल एक्लिप्स, अॅन्युलर एक्लिप्स, टोटल एक्लिप्स आणि हायब्रिड एक्लिप्स. खंडग्रास सूर्यग्रहण, कंकणाकृती सूर्यग्रहण, खग्रास सूर्यग्रहण आणि संयुक्त सूर्यग्रहण. आता आपण पुढे जाऊ. मला जे महत्वाचं तुम्हाला जे सांगायचं आहे, सूर्यग्रहण आणि डेव्हलपमेंट ऑफ ॲस्ट्रॉनॉमी. म्हणजे सूर्यग्रहण ही खगोलशास्त्रात मध्ये किती महत्वाची आहेत. सूर्यग्रहणाचा अभ्यास करताना अनेक गोष्टींची उकल झाली आहे. सोलार eclipses are so important that while studying those eclipses, scientists were able to understand so many concepts in astronomy. They were able to understand lot many things. We will take only 3 examples wherein we can understand altogether a new अंडरस्टँडिंग. फॉर एक्झाम्पल द डिस्कव्हरी ऑफ हेलियम. आणि हे फार इंटरेस्टिंग आहे आपल्यासाठी. तुम्ही जर वाचाल तर तुमच्या लक्षात येईल. मी वाचायला वेळ देतो जरा अर्धा मिनिट. हे फार महत्वाचं आहे. 1868 सालची गोष्ट आहे, जेव्हा आपण पारतंत्र्यात होतो तेव्हा बरेच युरोपियन आपल्याकडे यायचे आणि आपल्याकडे आपलंच राज्य असल्यासारखे वागायचे, म्हणजे फिरायचे. आणि त्यांनी बरंच इथनं काम पण केलेलं आहे. असं नाही की केवळ राज्य केलं, त्यांनी अभ्यास केलाय. सायंटिफिक एक्सपेरिमेंट्स ऑल्सो दे कॅरीड. सो वन सच एक्सपेरिमेंट वॉज conducted by two independent astronomers, Piers Janssen, who was Frenchman, and one was Joseph Norman Lockyer, he was British. Both of them observed the sun and they tried to understand the elements in the sun. आणि एकाने जॉन्सेननी गुंटूरवरनं, जे आंध्र प्रदेशमध्ये सध्या, आणि जोसेफ नॉर्मन लॉकियर यांनी दस्तूर खुद्द आपल्या इतिहास गाजवलेल्या विजयदुर्ग किल्ल्यातून, जो मालवण जवळ आहे, त्याच्यातून हे ऑब्झर्वेशन केलं. आणि विजयदुर्ग किल्ला हा साक्षीदार ठरला एका महत्वाच्या शोधासाठी, ते म्हणजे हेलियमचा शोध. हेलिओस म्हणजे सूर्य, आणि सूर्याचा अभ्यास करताना हे सापडलं. म्हणून हेलियम हे अत्यंत, जे अभ्यास करतात, ॲस्ट्रोफिजिक्सचा अभ्यास करतात, त्या सर्वांना माहिती आहे की हेलियम इज वन ऑफ द मोस्ट इम्पॉर्टंट अँड व्हेरी अबंडंटली फाउंड एलिमेंट इन द युनिव्हर्स. तर त्याचा शोध लावला गेला. त्याची ऑब्झर्वेशन भारतातून, आणि भारतात सुद्धा गुंटूर आणि मुख्य म्हणजे महाराजांच्या विजयदुर्ग किल्ल्यातून हे ऑब्झर्वेशन केलं गेलं होतं तेव्हा. सो हे एक महत्व आहे विजयदुर्ग किल्ल्याचं. त्याच्यानंतर प्रूफ ऑफ आइन्स्टाईन्स थिअरी ऑफ रिलेटिव्हिटी. आता रिलेटिव्हिटीवर बोलायचं झालं तर खूप मोठा विषय आहे हा. थोडक्यात सांगायचं म्हणजे आइन्स्टाईनच्या रिलेटिव्हिटीचा एक सिद्धांत असा होता की प्रकाश किरण एखाद्या स्ट्रॉंग, म्हणजे अत्यंत बलशाली अशा गुरुत्वीय क्षेत्र जे असेल त्याच्या जवळून पास होताना वाकतात. म्हणजे काय, तुम्हाला साधारण एक उदाहरण देतो, थोडंसं पटेल असं, की तुम्ही जर 4 लोकांनी एक चादर अशी ताणून धरली, 4 टोकाला धरली, आणि मध्ये मी एक प्रचंड वजनदार असा गोळा टाकला, तर काय होईल, हे जे चादर धरून ठेवलेली आहे 4 लोकांनी, ते असं मध्ये त्याला बाक येईल, बिकॉज ऑफ द वेट ऑफ दॅट हेवी बॉल. So what happens is that the chadar ji hai, that is can be analogous to the space, and the ball which I am putting in the on that cloth is nothing but the strong gravitational object. Say for example the sun. So whatever coming right behind the sun towards me will get bent by this strong gravitational field. तर गुरुत्वीय बलाच्या या अत्यंत मॅसिव्ह गुरुत्वीय बलाच्या सानिध्यामुळे तुम्ही एखादा प्रकाश किरण तुमच्याकडे येत असेल तर तो वाकला जातो. ह्याचा पुरावा 29 मे 1919 च्या सूर्यग्रहणात आर्थर स्टॅनले एडिंग्टननी जो एक्सपेरिमेंट केला त्याच्याने सिद्ध झाला. म्हणजे आइन्स्टाईनने जे काही वर्षापूर्वी सांगितलं होतं 1905 च्या आसपास, त्याची प्रचिती 1919 च्या ग्रहणात आली. So सूर्यग्रहणाचा is one more this example of what total solar eclipse contributed to astronomy. And one more thing lastly, हे example घेऊया अजून, की पृथ्वीचं जे परिवलन आहे, म्हणजे स्वतःभोवती फिरण्याचं जे पृथ्वीची गती आहे, ती हळूहळू कमी होते. आता मी जेव्हा म्हणतोय हळूहळू कमी होते, याचा अर्थ आता काही वर्षांनी खूपच कमी होणार आणि ती थांबणार अशातला भाग नाही. ॲस्ट्रॉनॉमिकली हळूहळू म्हणजे प्रचंड मोठा कालावधी असतो तो. तर ही जी कमी होण्याची जी गती आहे, ह्याचा पहिला पुरावा सापडला ते म्हणजे सूर्यग्रहणाच्या वेळेस जो सूर्यग्रहणाची जी कॅल्क्युलेशन केली गेली होती, एडमंड हॅले, ज्याला आपण हॅलेचा धूमकेतूच्या नावाने अत्यंत प्रसिद्ध आहे तो, आपल्याला त्या हॅलेच्या धूमकेतूच्या वरून आपल्याला माहिती आहे. बट Edmund Halley was entirely a different person. He was a genius. He knew so many things. He worked in so many aspects, and it is one of his mathematical skills that he undertook this project, and he rightly conjectured that Earth rotation is slowing down. फार डिटेल मध्ये आपल्याला जाता येणार नाही, वेळेअभाव आहे. पुढे जाऊया आपण. ह्याच्या खेरीजही सूर्याचा अभ्यास करण्यासाठी अनेक उपकरणं, अनेक अभ्यास सूर्यग्रहणाच्या दरम्यान केला गेला. कारण एरवी सूर्याकडे बघणं खूप कठीण असतं, सूर्याचं निरीक्षण करणं कठीण असतं, परंतु सूर्यग्रहणात जेव्हा सूर्य झाकला जातो तेव्हा सूर्याच्या वातावरणाचा अभ्यास करता येतो. म्हणून सूर्यग्रहणात बरेच प्रयोग केले गेले आणि त्याच्या सहाय्याने आपल्याला सूर्याच्या अंतरंगांची बरीच माहिती मिळाली. पुढे जाऊ आपण. नाव दिस इज व्हेरी इंटरेस्टिंग आणि हा कदाचित आपल्या या संपूर्ण स्लाइड शोचा मी म्हणेन क्लायमॅक्स असेल. कदाचित काही जणांना माहिती असेल पण काही जणांना माहिती नसेल, पण ही अतिशय इंटरेस्टिंग गोष्ट आहे की प्रत्येक ग्रहण जे असतं ते ग्रहण एक फॅमिली मेंबर असतं एखादं. आता मी असं बोललो तुम्हाला काहीच बोध होणार नाही, पण मी तुम्हाला काही फॅक्ट सांगतो इथे. हा, आता astronomers over a period of time they understood that the earth, moon and the sun. आता पृथ्वी सूर्याभोवती फिरते, चंद्र पृथ्वीभोवती फिरतो. आपल्याला सूर्याचे चंद्राचे सर्व ऑर्बिटची व्यवस्थित गणित माहिती आहेत. आपल्याला त्याची कक्षा कशी आहे, किती वेळात फिरतो, कशी प्रकारची ऑर्बिट आहे, किती इन्क्लिनेशन आहे, किती एक्सेंट्रिसिटी आहे, एव्हरीथिंग विल नो. आणि ह्याच सगळ्याचा वापर करून असं लक्षात आलं की साधारणपणे 1585 दिवसांनी पृथ्वी, सूर्य आणि चंद्र हे आज समजा एका विशिष्ट परिस्थितीत असतील, एका विशिष्ट पोझिशन मध्ये असतील एकमेकांच्या, तो आफ्टर 685 डेज दे अगेन कम इन टू द सेम पोझिशन विथ रिस्पेक्ट टू इच अदर. म्हणजे कसं, फॉर एक्झाम्पल समजा आता 21 तारखेला ग्रहण आहे, 21 जून 2020 ला एक ग्रहण आहे आणि आपण जर का बघितलं.
हॅलो शिशिर, सॉरी टू इंटरप्ट. Can you just hold your mic little closer to your mouth because your voice is breaking? And another thing is, can you just conduct this in English because some people are requesting to conduct in.
I was told that I should use both languages. That is why I was using it. But I will describe in English also. Fine.
Okay, sure. Thank you.
Yeah. So, okay. So, for example, if we know that on the 20th June 2020, 21st June 2020 there is an eclipse. So if we apply this particular thing to that, so we take 6585 days and we go back in time and see if prior to this 21st June 2020, if we deduct 6585 days, can we check if there was another eclipse? We'll see that. By the way, these 6585 days are equivalent to 18 years and 10 or 11 days. 18 वर्ष आणि 10 किंवा 11 दिवस असं होतात. So this is very easier for computation because 6585 days to reduce 6585 days from any date is very difficult. But if I say it is 18 years or 10 or 11 days, the matter becomes much more easy. So in short, what happens is that after every 18 years and 10 or 11 days, depending upon the intervening leap years, the sun, moon and the earth come in the same position with respect to each other, and hence eclipses are repeated. So we'll see that now. And this chain of eclipses is called Saros. And it is one of the most beautiful, most interesting aspects of eclipses. I remember one such day when our Mone sir explained me about this Saros. I was really so amazed that I started learning more about eclipses, and in the end I could write one book on it. So this is very interesting. Let us see now. We have taken this example. This is a 21st June 2020 eclipse. Next Sunday we have eclipse. So if we go back in time and check whether if we deduct 18 years and 10 days, is there any eclipse? Yes, there was an eclipse. 10th June 2002, there was an eclipse. If we still go behind, 30th May 1984, there was an eclipse. 1966 there was an eclipse. कब तक चलेगा ये? Few more, and few more. Just note the earliest date, 25th May 1389. Okay, fine. But what about future? Okay, we'll try. After 21st June 2020, if we add now 18 years and 10 days, let us see. One more, few more. Fantastic. So that is mathematical astronomy for you. I think my point is, by this logic, I have learnt you that, I have taught you that, I would say that, I have taught you that if I give you one eclipse date, you are in a position now to predict the next or previous eclipse, aren't you? You can do it, right? Just add 18 days or deduct 18 days, 18 years and 10 days. Then you will have one more eclipse. So without going through rigorous mathematics, now you are able to know the eclipse and its chain. It's a chain of eclipse. So this particular eclipse is 21st June 2020 is having these many family members. So collectively these chain is called an eclipse family or a Saros family. Now we'll coming to towards the end of this presentation. Quickly we'll go through the 21st June 2020 eclipse. As I told you about the family of eclipses, this particular family is having a number 137. This is a 137 number family. Again, I'm taking that family. And what is the speciality? What are the main features of this family? We would say, in other words, we will say that what is the biodata of this family. So here it is. This Saros family number is 137. Total number of eclipses in this particular family is 70. It's encompassing a span of 1244.08 years. First eclipse, middle eclipse, last eclipse. And composition, in this particular family, we have 15 partial eclipses, 9 hybrid eclipses, 36 annular eclipses, and 10 total solar eclipses. And all these eclipses occurred only at near the one node, that is ascending node. म्हणजे राहू बिंदू पाशी ही सर्वच्या सर्व 70 ग्रहण झालेली आहेत. So you can just note that the middle eclipse coincide with the eclipse that we are very near to. 21st June 2020 is the middlemost of this family grant. That means this particular family is just getting matured. This is the middle of that family that we are living in. So at a particular point of time, there are many families running. Supposing after 6 months there may be one eclipse, and that eclipse will not belong to this particular family because the duration between this eclipse and that eclipse is not 18 years. So that eclipse may be running in entirely different family. So likewise, every eclipse belongs to a family, and at any particular point of time there are n number of families running. Some are towards the end, some are towards the beginning, likewise. So this is entirely a new topic. Actually it takes a whole 1 or 2 hours lecture to explain various aspects of Saros family, but for the time being we'll contend with this. So just now for all those participants, I would like to tell you the important resources of eclipses, where you can get the information of eclipses. These are some of the important resources of eclipses. JSFC NASA is a wonderful site. You can see lot of eclipse information on this site. Time and Date is a recent website wherein you can find animation of eclipses, eclipse, how eclipse is seen at different places. That is also mentioned on timeanddate.com. Then 5 millennium atlas of the solar and lunar eclipses. Then 6 million atlas. So you can see, just see the number. This is the number of year. This 3,000 years before and 3,000 years after. That makes a 6,000 year catalog of solar eclipses. That means astronomers have computed the dates of eclipses for last 3,000 years and next 3,000 years. See the sheer amount of work they have put in. So this should be appreciated. You know, this is the work. This is where we should get amazed how they could calculate this so precisely. How they predicted 21st June eclipse. This is something we should think over instead of those typical traditional queries. Okay, one more resource, very important for me and you. This is a book written by our Mone sir and myself. This is available in Ideal and Majestic and maybe in few stores in Pune. So this comprises of 150 questions on eclipses, and this contains a lot of dates. Question and answer is the type, so from any page you can start reading it. There are many chapters, figures, tables, appendices, diagrams, references, index, links, dates of forthcoming eclipses. Lot of information is there. Now lastly we'll come to the annular solar eclipse of 21st June 2020. So the path of, as you have already seen, the path of the moon's shadow can be drawn on the map. So this is the area, this is the Delhi, you can see Delhi. So this is North India, and the prominent stations from which you can see, this is the narrow band, you can see, narrow band, the purple band, and one red line is there. Red line is the center line where the axis of that shadow will pass through, and you can see the very narrow patch. So Suratgarh, then Sirsa, then Kurukshetra, Yamunanagar, and Dehradun. Dehradun is slightly above the center line. These are the prominent stations. We had also organized one Akash Mitra tour like we did in 2019, 2009, 2010. We also had arranged one trip at Kurukshetra, but unfortunately due to this COVID-19 we were compelled to call off that expedition. So we are probably on the verge of missing this beautiful event because of the current situation, but still we have not lost the hope. We are really need some help to to get ourselves there at that time. Let's see. Okay, so these are some of the cities from where how eclipse will be seen. From Mumbai it will be 62%. So still it is not bad. You can see there won't be any darkness because 62% is too less. Last time when the December eclipse, 26 December 2019, we had been to Kannur, Kerala. Akash Mitra had taken 80 odd people there, and we witnessed a beautiful annular solar eclipse. At that time the sun was obscured about 97 or 98%, but still that 2% was enough to brighten entire sky. So there wasn't a darkness, but substantial reduction of light. That is true. So 62% may not call for any darkness, but yet you can safely observe it. Although I'm very sorry to say the predictions of weather are not good for Mumbai because monsoon will be just settling at that time round. So these are various cities. This is the maximum phase where at that maximum phase how eclipse will be seen. And lastly, I would say what you do not do. Without proper filters, do not use any of these devices. Without proper filter, do not use any of these devices. And even if you have filters, don't keep staring at sun. Mujhe dekhna hai bas. No. You don't need to do that. Even if you are going few kilometers to observe it, just observe it for a few seconds, then come take off your vision, then again you pull on your glasses and then you see. Likewise you should do. Now what you can do is safest way to observe an eclipse, solar eclipse. There is no harm in, by the way, there is no harm in observing lunar eclipse by any kind. Lunar eclipses are perfectly safe to observe by any means. So that is one thing. Solar eclipses, by the way, is a different story. We need to be little careful because in normal circumstances we don't find any occasion to stare at the sun. So there is nothing that eclipse के time पे कुछ बौछार होती है, कुछ अलग किस्म के रेडिएशन के, ऐसा कुछ भी नहीं है. It's a normal sun, and as you have seen, it is just a shadow play, just normal sun, but sun is blocked by the moon temporarily. That's it. No special radiation, no harmful rays, nothing else. So this way you can observe, you can put up a hole to a cardboard and take a projection, and then you safely observe it. But while observing, their posture should make a difference. See, there are two kind of observers. Yeah. Some are looking at the sun, some are looking at the projection. So this is right. So this is right because we should look at the projection, and projection is safest way to observe the solar eclipses. So that way it is. But apart from that, there are eclipse goggles and filters which are available in the market. Because of this situation, I could not explore personally what all the goggles available in the market, but I could find a source which you can also tap, and you can get in touch with Mr. Suresh Sali. His number is here. You can contact him and get some goggles if you are really interested to watch that. But it is up to you. You have to take decision. You have to check it, and you have to take it. So this from using those goggles, especially not ordinary goggles, these are specially polymer films that is used for these goggles, which are perfectly safe for eclipse viewing. Use such goggles and observe the eclipse. So in the end, wishing you a clear sky and happy and safe watching. Thank you very much.
Okay, thank you, Shishir sir. Can you please turn on your video camera?
Yeah, just a minute. Yes. Am I visible?
Yes, sir, you are visible.
Yes, sir. Okay, so now I would request our volunteer Tushar to carry out the Q&A session. Tushar.
Sir, first of all, thank you for your great presentation. It was very much informative and covered all the topics regarding the eclipses. And it seems from all the behalf of all the participants, there are very few questions which have come in. So it is quite informative, and it was like all the questions were answered in your session itself. So very few questions which I have.
I can't hear you.
I request all the participants, if there are any questions apart from all the questions which I have recorded, feel free to drop in the chat box so that I can take that questions also. So the first question is from Vaibhav. He is asking how do we know when the Saros family starts or ends?
Yeah, there is no observational way to find whether a particular family is starting or ending. Normally, any Saros family starts with partial eclipses and ends with partial eclipses. So one crude way to understand whether a family is in the early stage of its life or ending stage of its life is the type of eclipse. If the eclipse is partial eclipse, then you can say that either it is initial eclipses or it is at the end. But it is only mathematically you can come to know whether that particular family is young or too old. So there is a complex mathematical algorithm wherein you have to put some inputs, then you will come to know what is the number of that family and what is the number of that particular eclipse in that family.
Thank you, sir. The next question is from Abhay. He is asking how many families of eclipses are present at a time.
At a time, there can be 70 odd families running at any point of time, because whole Saros period is of 70 eclipses. So at a particular point of time, that many families are in progress. So some may be just started, some may be at the ending, some may be in the middle, just as we saw number 137. So at different stages, those eclipse families will be in progress. So that is one thing.
Another question from Harish is how many solar eclipses normally happen in a year?
Yeah, this is a good question. Normally, if you see, if you make a simple calculation, you will come to know that there are more solar eclipses than lunar eclipses, in fact. It is contrary to general belief, because we are more often we come to know about lunar eclipses than solar eclipses. But if you see the trajectory, in the solar eclipse, the moon comes in between the Earth and the Sun, and Earth's orbit is this. This arc is bigger than this arc. The middle is the Earth, and moon orbit is this. So Sun is somewhere here. So this arc is bigger than this arc, because shadow falls in this way. So there are if this arc is bigger, that means in this bigger arc, if moon comes, there will be an eclipse, solar eclipse I mean. And if you take moon somewhere here, that means it's a position of a full moon, and that arc is much smaller than this arc. So lunar eclipses are less. But this is still contrary to general belief, because we see more eclipses, and there is a reason for that. Lunar eclipse, when it comes in the shadow of the Earth, what happens is that near the half of the Earth who is facing moon will be able to see lunar eclipse, because moon is small and Earth's shadow is very big. But at the same time, if you take solar eclipse, moon's shadow is very less. It covers hardly 1% of Earth's total area. So the area on which shadow falls, it's very less. So that is why if you take a particular vantage point on the Earth, then solar eclipses are rare. But if you compute the arc and just sheer number of eclipses, irrespective of where they are seen, then solar eclipses are more. So maximum there can be 5 eclipses, 5 solar eclipses, and as less as 2 solar eclipses in a year. Whereas there can be a year where there is no lunar eclipse. So solar eclipses are more plentiful than lunar eclipse. But if you consider one particular point on the Earth, then possibility of having moon's shadow under that point, over that point, that is very rare. So considering one point, solar eclipses are rare, but in total solar eclipses are more than lunar eclipses. That way it is.
Another question from Satish Patankar is whether the eclipse family, so the eclipse families basically do they disintegrate or change in the span of like time span, in the large time span?
Yeah, this is very interesting question. As I said, it's a vast topic, so I just superficially mentioned it. Actually, it has got it's a very good, fantastic mathematics involved in that. We consider here 18 years and 10 days, 6585 days, but we did not consider the fraction involved in that. There is a fraction. And it is because of that fraction, over a period of time, that fraction increases to such an extent that moon's and sun's position go far from the nodes, and that's why one point of time there is no eclipse. The position of the moon goes so far from the node that eclipse stops. That chain breaks, and that marks the end of the solar eclipse family. typically when the partial eclipse starts in a family, then that partial eclipse also, the degree of obscuration of that particular partial eclipse go on reducing. Supposing in one partial eclipse is a large partial eclipse, for example 60% of the sun is obscured, the next partial eclipse in that family may be 50%, then 40%, then 30%, and likewise one point of time it will go out of that limit of eclipse. That limit of eclipse is either side of the node, both side of the moon, some 18 degrees either side. So when the sun goes beyond that portion, then eclipse, that chain is broken. So that marks the end of the family. Because we should take into consideration the fraction part of that integer. We just talked about the integer part, 6585 days, but there is 6585.32 days. If you keep on adding that fraction, then it will break.
Another question from Mr. Dilip is, how many hybrid eclipses happen in one Saros family?
See, the number of hybrid eclipses, as you see, depends on the position of the moon in its orbit during when the family starts. Because what happens is that if a particular family starts when the sun is something closer to apogee. Apogee is the farthest point in the orbit of the moon from the earth. So that family, if starts around apogee point, that is the upper bhubindu, then all the eclipses in that family hovers around that apogee points. And at apogee points, what happens is the diameter of the moon is lesser than lesser than average. So in that family, large number of annular eclipses are there. Because moon's disk is small, it cannot completely obscure the sun, and family becomes an annular dominant family. Whereas exactly opposite is the case with the perigee point, which is the closest point to the earth, moon's orbit, the closest point to the earth. If most of the eclipse in that family are occurring near the apogee point, then what happens is perigee points, then at perigee the moon's diameter is slightly bigger than its average diameter, so it completely obscures the sun. So in those families there are large number of total solar eclipses. So we have seen two extreme cases, apogee near family, perigee near family, but in between there is also orbit. It's also orbit. It can be neither close to apogee nor close to perigee, somewhere in between. In that part, if the majority of eclipses are occurring, then there is a possibility of having hybrid solar eclipses. So that is the it is important that it is a mathematical quantity called true anomaly. The true anomaly of moon's position at the time of its first eclipse in the family, that decides what will be the composition of that eclipse family.
Another question from Mr. Amit is, does the position of Rahu and Ketu change or are they fixed?
Yeah, it's a good question. Position of the node also changes. They are not stationary. That is why you might have seen that Rahu's position, especially those who are working on astrology, they say that it is in this constellation and that constellation. It is true to that extent. The position of the nodes changes, but the thing is that its direction of moving is different than the sun and the moon. It is retrograde. It is called retrograde. That is Vakri Gati, ulte position la firtat. That is why if sun is making one revolution, from Earth's point of view, sun is moving in the entire sky. That is why I am saying that. So by that time, the position of the nodes also changes in the reverse direction, but their motion is very minute. So what happens is that they are moving in the opposite direction. That's why moons or suns meeting to them comes earlier than their starting point, because they are moving in the reverse direction. So they are not stationary.
One more question is, how long does an eclipse last, or how do we know if eclipse has started or ended?
Okay, it's a good question. Eclipse generally, if you see total solar, I'm believing that you are talking about total solar eclipse. Okay, for a while we will take a total solar eclipse. Total solar eclipse generally lasts for few seconds on an average, we would say. But there are special conditions. If those conditions are met, then the prolonged period of totality can be experienced. Prolonged period of totality can be experienced. For example, it is a shadow play. The Earth is moving from east to west, and Moon's shadow is coming from west to east. So it's the opposite direction. So it's a it is adding the velocity of these two. So that's why what happens is that the duration of totality is very less. But one point of time, what happens is that they are parallel. So at that time, if you must have experienced this while traveling in the, say for example, in a local train, if fast train is going at one time, it is overtaking. At one point of time, both trains velocity is same, they appear stationary, because their the deduction between subtraction between these two velocities is minimal. So if someone observing the solar eclipse at his overhead, that means sun is exactly on the overhead, then at that time its velocity on that particular point of time is less. So there is a possibility that at that time, for that observer, the duration of totality will be more. There are other factors also. The sun needs to be, the Earth needs to be farther from the sun, so that sun's diameter will be less. Moon should be closer to the Earth, so that moon's diameter will be more, so that more diameter of the moon will obscure lesser diameter of the sun, and the duration of totality will be increased. Theoretical maximum limit of maximum totality is 7 minutes and 31 seconds, and very close coming figure in the actual eclipse that is going to happen, which is having a totality, if I am not wrong, it is 7 minutes and 29 seconds. That will happen on 16th July in the 20th century, until 2189 something, 86. Year maybe slightly wrong. So under these ideal conditions, if those conditions are met, the duration of totality increases. The same the case with annularity. If you want to increase annularity, the difference in the diameter should be more. The sun should be bigger and moon should be smaller, so that the ring will keep happening. The ring will be intact. Otherwise, the sizes, if the sizes are similar, the annularity will last for only few seconds. Like in this case, in this 2020 eclipse, we have at least annularity for hardly 38 or 39 seconds. So these are the factors affecting the duration of totality or annularity.
Yeah, one more question is, the participants want you to just elaborate more on the helium findings, and also can you cite some more examples with relevance to the eclipse, the findings and everything.
Okay, basically there are many sources available. First of all, let me come to that helium finding. So this being India being the being ruled by Britishers, and there were several European colonies were in India active at that period of time. So Pierre Janssen, who was a Frenchman, who went to, because Frenchmen had a base at near Pondicherry, and Guntur was close to that. So Pierre Janssen went there. He started taking observation. Joseph Norman Lockyer, he was also astronomer from Britain. He also came and he observed that eclipse. That was an 1868 eclipse, August 18th August 1868 eclipse, and he took some observations. The upper atmosphere, once the moon obscures the sun, then the hitherto unseen portion of sun's upper atmosphere is seen. And when you study this region and you do spectral analysis of that region, you find what can be called as a spectrum, and wherein there are signatures of many elements. There are signatures of many elements. These signatures are called lines, Fraunhofer lines. Where that is a series of bright as well as dark lines. These are called Fraunhofer lines, which was discovered by Fraunhofer, astronomer named Fraunhofer. So, if you find that particular line at particular position of the spectrum, then you need to understand what is the position of that. If you want to, you have to consider, you have to compare that spectrum with your laboratory spectrum, so that you will come to know at so and so angstrom length what was the element, and that element was known or unknown. The same thing was applied, and they discovered that there was a signature of an unknown element, and since that element was observed from the sun, that was given name as helium. And this is how helium was discovered. Janssen as well as Norman Lockyer both are generally given credit. So Vijayadurg Fort, since it was in the path of totality, that was selected by Norman Lockyer so that he will not have any hindrance of people around us. So he set up his instrument in Vijayadurga Fort itself, and then he observed that event, took the spectrum of solar upper atmosphere, did analysis, and his analysis matched with the analysis done by Pierre Janssen, and that's how helium was discovered.
The last question which I'm taking. So the question is, can total solar eclipses family come from metonic cycles or only Saros cycles?
Yeah, very interesting question. See, apart from apart from Saros cycles, there are other cycles also, such as you said, metonic cycle. There is one more cycle called Inex cycle. These cycles are also there. See, if you are talking about these three bodies, Sun, Moon, and Earth, their period of revolution around the Sun and around the Earth, there are 4 or 5 number of months that can be described. The one month is the position, the time in which Moon completes its orbit from perigee to perigee, or apogee to apogee. Apogee or perigee are the farthest and nearest point in the orbit of the Moon. If you consider that as a cycle, one cycle, that comes to one type of month. It is called anomalistic month. Then there is one more kind of month which is from one phase to the same phase. For example, new moon to new moon, or full moon to full moon. So that makes a synodic month. So there are few kind of such months. If you put together all these statistics in one place, and if you see if there is any order, you will find that there are few orders coming out of it, such as Saros. Meton is also such a cycle. Meton cycle repeats after 19 years, and its calendar date exactly matches. Its calendar date exactly matches. But the problem with Meton cycle is that it lasts for only 5 to 6 iterations. After that, it breaks, because the lag between each eclipse is too large. So it keeps adding, and then that cycle breaks. So Meton cycle cannot go beyond 5 to 6 cycles. Same with the Inox family. Inox family also is a half integer of anomalistic months. I guess 255.5 anomalistic months. So that family also breaks after few cycles. It is the Saros family which is one of the best and which is going too far. It is pursuing for few thousand years. So Saros family that is why it is most famous family. But apart from that, you can take जसे लसावी मसावी असतात ह्याच्यामध्ये, तसं या वेगवेगळ्या फिगर्सचा लसावी मसावी काढला तर आपल्याला वेगवेगळ्या प्रकारची सायकल्स मिळू शकतात. But Saros cycle is the long-lasting one.
Thank you, sir, for answering all the questions. And on behalf of all the participants, again I would like to thank you for your informative session and answering all the questions. And due to lack of time, we are unable to take any more questions. If there are any more questions, feel free to drop in your feedback form, which will be given after the session ends, and answers will be directed to you personally. And on that note, I would like to hand over to Sachin to conclude the session.
Yes, Tushar, we really enjoyed this question answer session and the entire information given by Shishir sir. We really thank you on behalf of Maharashtra Seva Sangh Vidnyan Vibhag, and it was really fantastic to see your enthusiasm and your all the elaborate answers. It was all evident. I would like to announce one thing, that tomorrow also at the same time we are going to have a very interesting session on Chinese military strength. So I would like to see all the people again tomorrow. With this note, again you can see in the chats our volunteer has put up the link for the same. You can register. Still registration is still going on, so you can register for the same, and we will be sending you the feedback form link soon. Feel free to add your suggestions and feedback to us, which will help us improve our further programs. Thank you so much for joining in with us today. See you tomorrow. Thank you. Thank you, Shishir.
Thank you. एक मिनिट बंद करतो.